So before we start graphing it, let's recall when we have a times the function. So when we do that, that is going to be a vertical stretch or shrink of the graph by a factor of a. If we have b times x, that will be a horizontal stretch or shrink by a factor of the reciprocal, 1 over b. So graph of y equals a tangent of b of x and y equals a cotangent of b of x represents transformations of their parent function. The value of a indicates a vertical stretch if a is greater than 1, or a vertical shrink if a is between 0 and 1. The value of b indicates a horizontal stretch if b is between 0 and 1, or a horizontal shrink if b is greater than 1. What this changes is the period of the graph, much like it does for sine and cosine. So let's look at period and vertical asymptotes. The period and vertical asymptotes of the graph of y equals a tan of b of x, where a and b are non-zero numbers, are as follows. So the period, if we notice from the parent function, the period is pi, and so we would have pi over b, and its absolute value of b. The vertical asymptote would be at pi over 2 times the absolute value of b, and the halfway points would actually be pi over 4 times the absolute value of b, comma a, and it would be the negative pi over 4 times the absolute value of b, negative a. Now I give these to you, and you probably may not use them because you really just have to think about what is the period, then you're going to cut it in half in order to figure out the asymptotes, and you cut it in half again to find out what the halfway points are. So that's really what you have to think about when you're graphing tangent. So here is an example. Let's graph g of x equals 2 tangent of 3 of x. So the first thing you do is you think about, what is the period? What is the period? So the period of this graph, remember for tangent, it's pi over b. So when we know in this case that a is 2, b is 3. So our period ends up being pi over 3. Now we have to think about our asymptotes. Where are the asymptotes? So thinking about the asymptotes, it's just half of whatever the period is. So that's why it's pi over 2 times 3, which ends up being pi over 6. So we have pi over 6 is where our asymptotes will be. And I go 2 out, and then I go 2 out on the left. So this is where my asymptotes are. And actually, if you think about it, we can look at the period, negative pi over 6 to pi over 6. That should equal pi over 3. And in fact, it does. Pi over 6 plus pi over 6 equals 2 pi over 6, which is pi over 3. Okay? So, now that we have our asymptotes, now we need to figure out other points. Another point we need is the halfway point. So just think about that. Half of pi over 6, that's just taking pi over 6 and multiplying it by a half. That's actually pi over 12. So these points right here, this is positive pi over 12. And on the other side, negative pi over 12. We just cut it in half. For tangent, our graphs start at 0, 0. So we're not shifting these left or right. So if it's not shifted left or right, then it starts at 0, 0. Now we look at our a value. Our a value is 2, so that tells us that it's vertically stretched by 2. So it's going to go up 2 and then down 2. So we know that if we're at pi over 12, then we're up at 2. If we were at negative pi over 12, we're down at negative pi over 2. So these are the minimum amount of things that need to be labeled on this graph. So here is our graph. It's going to get closer and closer to that asymptote, but not touch it. And those are the important points for tangent. Okay, so you need to show these 3 points. You need to label the 4 points on the x-axis. So that's, you label the asymptotes and the halfway points, and then you label the y-axis as well, those points there. So go ahead and pause it and try this example below. Graphing g of x equals 5 tangent of pi of x. And then I will show it to you when you return. So we tried this out. The period again, is pi over b. And our b value is pi, so it's pi over pi. That means that period is 1. So we know the period is 1. In order to find out where our asymptotes, it's half of 1. So half of 1 is 1/2. So here is a half, here is a half, and those are our asymptotes, -1/2. Now the other point we need is half of that, which is 1/2. Half of a half is 1/4, and this is -1/4. Now we know that tangent is at 0, 0, 0. And we notice that it's stretched by 5. The a value is 5. So that means I go up to here for 5 and down to here for -5. So to graph the points, I would be at right 1/4, up at 5. And then left -1/4, I'd be down at -5. And here is a graph for 5 tangent of pi of x.